Good afternoon, everybody. Welcome back to another episode of Built by Getroman, live code with Getroman. Thank you for showing up today. Today we'll be covering CodeWars, specifically code katas. We'll be focusing on AQ katas for this episode and tackling just one coding challenge. We're going to approach it with the same structure with the REACTO problem-solving technique. And let's see how it goes. This is the first video, the first installment of live code with Getroman, specifically with CodeWars. So I'm excited. My goal is to reach 500 points on the AQ filter. So let's see how it goes. Stick with me. Don't go anywhere. Let's get it. All right, guys. So let's jump right to this. Let me set up. Actually, I'm not going to set up the timer yet. What I'm going to do is actually go to the website and log in here. Hope everybody's having a great day. I'm having a fantastic day. I had to update you guys, I had a couple good interviews yesterday, back-to-back interviews with a potential company. And it's the farthest I've gone in the deepest I've gone in the interview process. So hopefully that there's some traction there and that transpires to a job offer. We'll see. So I'm gonna do a video on that as well, like, you know, my process and what I went through as far as like coding interviews and just interviews in general as a software engineer. So hopefully I can get that to you guys pretty soon, and I will. So all right, guys, so I want to let's pick our coding challenge. Let's pick our kata. I want to filter some of this stuff out. So for those who have not seen the video last week, actually, yeah, earlier this week, I posted a video on intro to CodeWars, and I just kind of went through the filters and like how to sign up, how to choose a kata, how to pick your difficulty level, and you know, AQ down to 1Q. I was pronouncing it wrong, so thanks for the person who did correct me. I forget. Actually, it was an individual from Code Immersives in the coding bootcamp out there. He picked it up, so thank you for that. And so AQ to 1Q difficulty, and I went over tags as well. So feel free to look at that video. It's in the playlist. Also, like and subscribe if you haven't. I would highly appreciate it. It will help with the YouTube algorithm and in regards to, like, you know, the discovery of my videos for you and others to actually watch them. So a lot of work does go into this in preparation. All right, so let's start filtering this stuff out, and then I'll start the timer, and then we'll proceed to go through our problem solving technique. All right, so I'm gonna go with most completed here. So there's a sort by option. Yeah, most completed. I guess that'll generate some more mature coding challenges that have like are very clear and not too confusing. I'm gonna choose my language, which is JavaScript. Right, actually, let me make this a little bigger. And I am going to go with approved, progress, katas I have not trained on. All right, let's see what happens here. So now I'm going to select my difficulty, AQ. Awesome. All right, I'm not in the way, am I? Okay, as far as filters, let me hide myself for a hot second here. Where's my camera? Where's the camera button here? Mic to mail. There we go. Boom. All right. So as far as tags and filtering, I'm going to focus on fundamentals for now. And then, you know, I want to work my way up to 500 points on fundamentals, and then kind of work my way down to data types, algorithms, on the AQ difficulty level, and try to go through actually all of these, this whole list here, all of these, and generate 500 points for each one. I know it's a lot, but hey, you know, practice makes perfect, and I'm just looking to repeat and rinse until I get to the point where like it comes like, you know, it's as simple as like drinking a cup of water. You know, it just comes to me. So I encourage everyone else to do the same. Okay, so let's see here. I'm gonna choose fundamentals. All right, so I have my most completed filter up. All right, my language of choice is JavaScript. Status is approved. Kata I have not trained on. I chose 8. I'm gonna choose 8 again. I don't know why that 6 is popping up. I guess it like resets the difficulty filter. But anyway, I think we're good. All right, so I'm gonna go with the first one. It says even or odd. It looks like a, you know, one that's been solved and completed a lot of times. So we're looking at 123,626 devs have solved this. I'm not sure what this is. Satisfaction rating 89%. So looks like it's a good one. So let's go with this one and see what this brings us. So all right, and I'm gonna start the timer here. So we're in our time box and we're good to go there. So we're gonna enter into the R phase, which is this right here of the REACTO problem solving technique, which is the reading repeat part. So we want to make sure that, we're repeating the question and getting an understanding what they're asking for. We'll dig into the actual kata in a sec, but this is like the higher level explanation. So it's saying create a function or write a script in shell. Interesting. I'd rather create a function to keep it simple for now that takes an integer as an argument and returns even for the even numbers or odd for the odd numbers. Okay, so let's train on this one. Okay, so it's the same explanation. The tags available are fundamentals. There's some mathematics involved, algorithms, and numbers. So these other tags kind of come along for the ride, even though I didn't choose them, but it falls under those tags as well. So if I were to choose mathematics with algorithms, then this would have came up. But it's okay. Let's see what the output is saying, which is nothing right now. There's no additional information provided to us. So the only thing else I can go with as far as the explanations are concerned is this part here. Let me get out of here. Let's make this bigger. So here's the unit test they have for us. So it's saying even or odd. Let's go with the first one here. Let's go with the last one. This kind of thing is in the way. So I'm reading this right here. Okay. So even or odd. We call the function, we pass in 1, and we're supposed to get odd because it's an odd number. Okay. The second one, kind of the same. We pass in 7, we get odd. Let me go for this one here. Even the odd 0, even number. We should spit out a string that says even. Okay. So basically, we will call this function 3 or 4 times, and whatever integer that's being passed in, we have to return a string defining whether it's even or odd. So it seems pretty straightforward, but I don't want to take it for granted. And I kind of want to see if there's any edge cases. So what happens if I were to pass... well, let's write this down, and I can kind of jot down some of the notes that I'm thinking about, some edge cases. Let me make this a bit smaller. Kind of hard to see there. Bingo. All right, so we're at the repeat phase. All right, so it's asking us, let me go back to the question here. There you go. Create a function or write a special script that takes an integer as an argument and returns even or odd numbers, even for even numbers and odd for odd numbers. So based off that test, we understand that this here, that these are straight integers, like positive integers, right? So this is the test that they're giving us. This is like hidden tests as well. So these are kind of like the ones that are obvious for us. So let's just get those out the way, right? So in the event that, this function gets a 2, which is a positive number, it should like basically return oh, I spelled that wrong. A string that says even, right? That's cool, but I'm not seeing, so edge cases, like that's obvious, like that's straightforward. So I'm just anticipating any like edge case here. So what is the edge case? So I'm anticipating some like some hidden tests that have maybe some numbers, like what happens in the case of if I don't pass anything, if it's empty, like if I pass, if I say function that has an empty string, right? An empty string, or just empty number, or just nothing. If I'm just calling it with nothing, right? It passed in. What happens? I need to account for that, or a different, you know, a different data type. Right? What happens there? If I pass in a string as a number, because here is just giving me a number, an integer, straight up integer. But what if they pass me a string as an integer, or just a string with a number, right? So do I chorus that or change that to a number? Do I have to like convert that? So that's an edge case that I'm not sure if they're like, you know, they're throwing some gotchas in there. They're throwing some like weirdness, because they do that. And sometimes it throws you for a loop, because you think you have the answer because you passed like the initial test case, but then like when you run it, it's like, oh wait, what's this? Like I didn't account for this. So edge cases is the thing I'm like starting to get better at and think about in advance. What are some of the things that are potentially could be passed in as an input to that function, right? So the three things I like to think about when I do these coding challenges, and I'm big on acronyms by now, you probably noticed that. So it makes things easier for me in life. But IPO, which is not the, I think like in the stock market, they use that as an acronym for something, but I use it for input, process, and output. And it's something I learned through one of my mentors at my coding boot camp. So basically, you know, what's coming in as an input, right? What's the process like? So what's the logic inside of it? What's the nuts and bolts of that function? And then what's going to be the output, right? So it makes you think a little bit more. So right now I'm thinking about the input here, right? So I'm thinking like edge cases as an input. What's being passed in? Like what's being passed into the function, all right? So in the event that it's empty, what happens? In the event that there's a different data type passed in, what happens? What else? What are some of the edge cases that could happen for us or to us when we run the test? Different data type, nothing at all, like an empty string. Oh yeah. What if they pass an integer, but a like negative integer, like -1? Or what if they pass in -10? Like what do I do here? What do I do with this in the event that they're passing a negative integer? So that's another edge case to think about. I'm gonna spend like another 2 minutes think about another one, and then we'll move on. Any other edge cases? So I have even or odd integers. I'm returning a string. Is there, what happens? Are they asking for anything else in terms of, in the assumption that there's nothing passed in? Do they want us to return a specific output? I'm not seeing that here. There's nothing saying that like we should assume that there's always an integer passed into this function. Like there's none of that, right? So we kind of are left out with that. We don't have that piece of information, so we can't make that assumption. But I'm gonna make it anyway, just because like in the event that there is, I can capture it, right? So I'm gonna account for all these edge cases in the function. It's probably overkill, but I just don't know. Like I'm trying to unveil the black box of what they're asking me for. So if they're not asking for that after we run the test and see some exposure on the behind the scenes unit test, then we can like optimize it a bit more to, you know, cut down some lines of code in that function to just account for what they're asking for. And that can probably come in the optimization part of this problem solving technique. Okay. So what else? What other edge case? So we have an empty string, a different data type. Let me just make some notes here. My handy dandy tools. Right. So we have different for the different data type. We have a negative integer, actually two negative integers. What do I do with that? So empty and different data type. What did they pass? For whatever reason, I don't know, an array or object, a string, some other like weird data type, some primitive data type in there to throw me off, and like my function's not like counting for that. I can't think of anything else, so I'm gonna just move on from this part. All right. So I'm gonna assume for now that yes, I do get integers based off this test, but I'm also gonna assume and account for different type of data types being passed in. Right, so different types of data types being passed in into this function. 2071 are straight integers, so I'm going to account for those. Going to account for those, and yeah, I think we can get into the E part of this, of the problem solving technique. I think I'm done repeating this and trying to figure out repeating the question, and forgive me, but I'm blanking out on the E, what the E stood for again. Examples, yes, which I kind of did. So I kind of did the R and E together, I think. So let me think about this. Is there anything else on the example side that I need to account for? I don't think so. I would probably need to, like, for the example part, probably just write some examples out. Like, let's do that. You know what? We have 10 minutes. Let's get into the example part of this coding challenge. All right, so let's drum up some examples here. Okay, and let's just, you know, run it through one more time. So I'm gonna actually cross off the R here. So we're at the E part of it, and I'm gonna cross that off as well. So some examples of what I'm thinking, which I'll probably repeat the edge cases a bit as well. So if I have a function here that has you know, passed in the number 1, is it no, it's an integer. So I need to say something along the lines of, like, if I were to get 1, I would need to, like, it's probably safe to say that I would need to do some math in here, right? Some math of some sort that finds the remainder of that number. So is it odd or even based off, like, was it the modulus? Am I spelling that right? Let me see. Modulus. MODULUS. Is that correct? Yeah, MODULUS. All right. Right. So is this odd or even? And I return that. Return string even or odd. So I'm just expanding basically the repeat part, this, right? So so these two kind of go hand in hand, right? So like when I'm interviewing, I just, typically the repeat part, I would repeat and speak with the interviewer to get a more defined what to ask for. Then I will give examples. So in this part, I kind of did both at the same time, but just for practice sakes, I'm going to like separate them, just so that I can define them. Oh, what happened to my time here? My clock. There you go. All right, so yeah, example, passing the function number 1, math finds the modulus, whatever the remainder is. If there's nothing left over, is even. If there's 1 left over in the modulus, once the like operation is done, then it's odd. And then I return a string. All right, so another example could be here. Let's see, I'm gonna write this at the bottom. So for one of the edge cases, if I don't know if I'm past like a negative number. If I'm past a negative integer, do I need to convert it into positive? Is that even necessary? Do I need to do that? Or because it's on like the negative side of the spectrum, and do I need to convert that to a whole number? Maybe I do. I'm gonna do it. I'm gonna convert this to a whole integer. So int for short. Then I don't have much space here. Then I'm going to do the rest. I'm gonna just put dot here to do all this part. The rest of the that's what that means. So this dot is basically the rest. Like find do the math. Then is it odd or even? We'll do some logic here, some logic, and then return even or odd. So this part, this example, is one of the edge cases, right? Edge case. Okay. All right. One more. I'm gonna actually account for. I'm gonna write it up here on top. So what if, for this example, the last example here, what if we were past a different data type, right? So we're actually over here, just so that you guys, we're focused on here now. What if we were past a different data type? Right, so here, if I were past a string, the string number 1, then what? Do I just say, sorry, this is not a number? Right? I feel like that's the only case I have to go with because I don't know any more information about this until I run it, right? So I was like, return not a number, something along those lines. So if this is a string, an object, array, I return not a number or something to that effect. All right. As the piano's playing in the background. Yeah. So I think I'm good here. I think I want to kind of move along to the next section, which is the approach I'm going to take as far as like defining the type of approach. All right. So real quick, so I repeated the question. So as far as my problem solving is concerned, I repeated the question. Typically I would, be talking to some interviewer to get more anecdotes on the actual like coding challenge, to juice as much information as I can, because I don't know exactly what, besides from what I read, it's good to talk to the interviewer. So I've done that before, and then get into the examples once you gather information from them as far as like what edge cases you can get into, possible edge cases, right? The possible edge cases here. Then you kind of walk through like what could or could not be as far as the input's concerned, so you can account for those. Then I went through the examples here, and this is where like in the interview, I guess it'll be a little different. Like it would be more of a, you would kind of write it out on the whiteboard or some form of writing code, whatever resource they use, some Scratchpad, and you kind of map out exactly what like could happen in some pseudocode, I guess. So we did that. We wrote the example. We repeated the question. I think I'm good here. And what I'm gonna do is actually take a break and then get into the approach piece of this, which is kind of just talk about exactly which approach I'm looking at, whether there's going to be iterative, recursive approach, or like a heuristic approach. So enjoy the break. We got a minute left, so we're going to cut it short here. Enjoy the break, and I'll see you guys in a couple of minutes. All right, guys, we're back here. So let's get into the approach part of this coding challenge, and this is basically where I kind of like quickly think about how I want to approach this coding challenge from an iterative or recursive or heuristic approach. So being that, so I'm thinking, going back to the test here and some of my notes, that being that I'm only passed one integer at a time, unless they pass an array of integers or some collection of integers, which they didn't say, but you know, I've seen wonky coding challenges like that where they don't say it, but they give it to you as a edge case. So for now, I'm not gonna worry about it, but I think because of the way I'm looking at this and looking at the examples that I've actually put together, that I think I'm gonna say, actually let me set my timer. Totally forgot about that part. There we go. So and actually, so this is part of one of my questions I put out there on Twitter. Like, I'm not gonna iterate through this, right? I'm not gonna use any recursion. The last one that I've learned about was like heuristic programming, and I've heard that term being flown around. So I truly am still confused about what that is. My assumption is that, and from what I read and what I understood, is more like of a quick mathematical way of approaching things. Like, not really think about the logic as much, using some quick math shortcut way of solving a coding challenge. So correct me if I'm wrong. Like, what is heuristic programming in your own words? Leave a comment below. Let me know what you guys think. Or tell me what that is. Give me some examples. Point me a link to some cool example. If you have a video on it, then like link me to that as well, because I'm trying to like really define what that is. Because like when it comes to like the mathematical stuff, when it comes to like these coding challenges that deal with like hardcore math, I'm wondering if there's like a word to categorize that. And I'm hearing that like heuristic is like, and I'm seeing heuristic programming being tossed around. So maybe that's the fit. I'm gonna go with that now. So please correct me if I'm wrong. And what I want to do now actually is make sure that, oh, not my Gmail, guys, no. I want to make sure that I'm spelling that right. Heuristic. Heuristic programming. Let's look it up real quick, and then we'll move on. Heuristic programming is characterized by programs that are self-learning. They get better with experience. Heuristic programming does not always reach the best result, but usually practice a good result. So maybe not. So how do I categorize, maybe a review, how do I categorize this as like, I'm not using an iterative approach. I'm not using a recursive approach. So what's the last one? Like, what am I doing then, since I'm not working with loops or anything like that, recursion? I'm doing more of a like math. It's a mathematical equation. So is it another word for it? But I'm going to use this just because I need something to reference. So my approach is going to be a heuristic approach. So please comment below as far as like what's the proper name for this. Is there a name? Because it'll be helpful for me as well as for the folks that are watching. All right, so let's do this here. Close that a bit. So I'm going with a heuristic approach. So my approach is this. I think I'm gonna, if I look back at my notes, I wanted to do some modulus here. So basically I wanted to say, you know, take the num that's being passed in as an argument and say, how do I find the odd or even again? Is it num divided into 0? How do I do it again? I've done this a million times. You forget. Modulus. So find out of even modulus. JavaScript. I use it in FizzBuzz like 1,000 times. As you know, I always look things up. It's all right. Oh yeah, so divided by 2 with nothing left over. Right? That's even right here. Okay. So I'm looking at this part. Right? We do this with FizzBuzz. If it's even or odd, you spit out fizz. If it's, you know, divisible by whatever number, you spit out buzz, etc., etc. So there it is. All right. So I'm gonna go with this. The approach is just basically this is like the bulk of it. I don't think I need to loop through anything, right? I'm not using a. I don't think I'm using an iterative approach. If every time this function is called, it's just one number being passed in. So I take that number, I take this number 7, plug it in here, so we get 7. 7 divided by 2 has something left over, which is 1. There's 1 left over, right? And this whole thing is going to equal to false, which translates to odd. Okay, so I'm gonna go with this as the approach. I'm not iterating, I'm not doing anything like that. So let's just go with that and move on to the pseudocode part of this coding challenge. So let's do it. All right, so we're at the pseudocode. Let's close this up a little bit. And let's use our notepad here. I'm not gonna write it down this time. I'm gonna actually like type it out. All right, so let's say this. Let's go back to our first page here. Let me make this bigger. I still have space to play with. Awesome. All right, here we go. So I want to do some pseudocode. So I'm going to say I want to first tell you what, I'm going to, let's grab, so grab the number and store it in its own variable. Oh, this needs to open a little bit. For immutability purposes. So yeah, I always have a habit of like, since I'm doing React now, I've been doing React for a little bit, but you know, I'm getting better at it now. I always have this mind of like taking some input and like creating some state for it and like just having a reference to it so I don't mess with the original input being passed in. So I typically do that, and the way I'm doing that here is simply just store it in the variable, call it something else. So there's 2 reference points to it. For whatever reason, I like to do that. So I grab the number, then create another point of reference slash variable. That holds the the mathematical, did I spell that right? Part that holds the mathematical, no, that determines, that's not a good word, that determines the modulus, which in turn will determine whether the number is odd or even. So I'm gonna have a variable that does that for me. Like I'm gonna just do an equation, store it in the variable, and then use that reference to the variable, the label to the variable, in the logic itself to be like, hey, is this thing equal to 0? If it is, it's even. If it's 1, it's odd, and return that, basically. Okay. So that's that part. Okay, before I get to the logic, actually let me just account for the code part here. Just put some notes. Okay, I can actually use the notes here. So let's drum out our like logic table, or yeah, is it called a logic table? I think it is. Let me look that one up. I'm also doing this thing called Brilliant, guys. So whoever's like into puzzles and problem solving skills, look at Brilliant. They're awesome. There's a cost to it though. I pay for the year, but it's something that I feel like is very helpful for me. Is it Truth Table? I guess it's called Truth Table. There's something in Brilliant that had me do it, truth tables and the ifs and the elses, and I kind of walk down like a thing. It was very helpful. But look it up. So I'm gonna do that here. So in the event, so it can help me drum out my logic for the edge cases, right? So for these edge cases here, I'm gonna just do like a logic table so when I write it out, I'm gonna draw it out first, and then I'm gonna type it out and then code it. All right. So in the event of I'm past an integer, right? So here we'll say if 0 return the string true, right? If 0 return true, then here we're gonna say, do I extend it out here? Else, or is it here? I think it's here. This is my first time doing something like this. I'm a very visual person, so I like to see it. So I'll just add it here. If 1, we're going to return I'm sorry, not return true, return, this is odd, this has to return even. Okay. On your end, it looks a little funny. It'll correct itself. But basically, this is even here. This part is even. All right. Just annotate that real quick. Cool. So in the event we're past an integer being passed in, no funny business. That's pretty straightforward. If it's 0, we do some math. If it's 0, return even. If it's 1, return odd. All right. Another approach to this. So that's part of the logic. So I need to account for that. Here, what's the other one we said? We said it could be a different data type. So if I'm return the string of 1, then here I need to say, So this is one if statement, I think. So you know, if whatever I'm calling this, if num is equal to if the type of num, there we go, if type of num, and this is the edge case. You know, I'm probably doing extra here. It's probably not necessary, but I just don't know. I don't want to assume. So if type of num does not equal to a like string, I guess, something along those lines. Does not equal to a string, then like return not a number. Return not a number. Okay. And the other piece of the logic would be, what's the other thing we accounted for, which was over here, the edge case, a negative integer. I mean, I guess having a negative integer convert. I'm gonna hold off on this one. So like if one of the tests, when I run it, if the test is, if the input is giving me a negative integer, then I'll just go back and account for that. But at least I have it here as an example and I'm thinking about it, but I'm not gonna include it in the logic. So I'll hold off on that one. All right. Okay, so let's just write this out in the pseudocode. All right, so we're gonna say if here. So if, so as I get the number, if, and I don't know what I'm calling it yet. Num, I'm gonna call it num because this is number, because I'm storing it again in a different variable. If num is equal to 0, then return the string of even, else return the string of odd. I'll just put that in some strings. Ooh, what was that? I've done that before. Right, that's this one. If so, this one is, now this is the edge case, one of the edge cases. If in this event, so if the num does not equal, if the type of num, yes, because it's dealing with data type. So if the type of num I'm saying here, if the type of num does not equal the data type of string, I gotta look that up too to make sure that when I use a type of clause, I'm doing it the right way. So if the type of num does not equal a string, that'll pretty much get rid of all of the other edge cases, I think. If it's an arrays and the object or negative integer. I'm not sure about the negative part. So if it's, all right, boom, then we want to, I guess, return not a number. I don't know if they want that, but we're gonna go with this. So this part, right? This is I think that's it. We're gonna just stick with this piece here. Okay, we're 6 minutes left. Okay, and I think that's it for the pseudocode for now. Let me just do a quick review to make sure. I just feel like they're gonna hit me with the negative integer, just because my, that's the way CodeWars works. They throw you these curveballs. So this negative integer part, I gotta think about a little more if it doesn't pass. Okay, so grab the number, store it in its own variable for immutability purposes. Okay. Create another point of reference as the variable that holds and determines the modulus. If the num is equal to 0, return the string even. If else, return the string odd. An edge case, as far as the input, could be that the data type is not an integer, it's probably a string or something like that. So I'm accounting for that one edge case. I didn't account for the other, the negative integer. And so in this one, if the type of num is not a string, I can return not a number, I can return false. It may be overkill for this problem, but I just don't know. That's why I'm holding off on the negative integer part over here. So cool. All right, guys, so let's take a quick break, and when we come back, we're gonna do the actual coding part of it, right? The syntax part out. And once we're done with that, then we'll run a test on it and take it from there. All right, guys, so enjoy your break. Thank you. All right, guys, we're back. So let's get right into the coding piece of this. I'm going to actually remove myself from the scene just to give it more. Oh, not yet. Actually, we have space, so we're good right now. All right, so let's comment this out. And let's get to the code. I think I am going to remove myself. All right, just for a hot second, guys. All right, so I'm going to grab here. We go. So let's get this. So the first line says grab the number and store it in its own variable. So we're gonna take number. I just call it num equals number. Probably overkill, but I'm in the mindset of always having some state involved into my writing of a function, if you will. So create another point of reference. Let me see. I'm not in the way yet. All right, create another point of reference to do the actual math, right? So let's say is even or this is probably the worst variable naming convention. Is even or is odd. So I'm gonna say create another point of reference. And I said here is gonna be num modulus 2. Okay. And I'm gonna log this part out. I'm gonna console.log that number out. Just to see what's being spit out on the console when I do run this. Okay. So we have number, hold some state, is even or is odd, which does the whole modulus thing. And I'm gonna run it and see what kind of results I guess. Where is the result being pumped? Oh, here we go. Kind of small. So let's open this up a little bit. Syntax error. Where exactly is my syntax error? Unexpected identifier. Do I have to wrap this? Let me just wrap this in parentheses and get rid of the, maybe do that. Okay, create script. Where is the unexpected identifier? JS 80, 10, line 10. Everything is in commented out. Let me run this in the console real quick. I'm not sure what's going on there. So let's just say, let me copy this line here. I'm missing something very, very small. Right? We got this line. I have this line. And I want to log it out. Right? And I call it. Oh, they put the timer on. I always think about this timer. All right, we got some extra time. No worries. All right, I'm gonna call this here and pass in a number, and I'm gonna say 2. I don't know. It's spitting out true. So I guess just like because I didn't finish it in CodeWars, I didn't finish out the whole function. Since I didn't finish the whole function, it's probably just like not understanding what I'm trying to accomplish. But in the dev console, it does tell me that it is true. So there's some truth to it and it's working. All right, so that confirms that part. And let me open this back up. All right, so let's move on. I'm getting some responses. That's all I wanted to see there. And what I want to do here is basically, what's the next step? The modulus, we get that. So let's go into the logic. So if, what did I say? If num is equal to, if it's even, so it returns a true or false, right? So if it's true, then return the string even. Else, you know, pretty straightforward. Return they want odd, right? Edge case. I'm gonna run it without the edge case. And if there's some tests that are, you know, acting wonky, then maybe it's because of the edge cases. So I'm gonna have my phone here. Excuse me, my camera. And let's run this. At the bottom here. See what do we get. Test one more time. It's still giving me a weird error. Is it the comments that's acting up? Test assertion even or odd one. What is this thing here? Did I do something? Oh, what is this? Look at this. Where does this come from? What is that nonsense? What is that? So I might have hit the key by mistake. So this is, remember in the video before this, if you see my intro to CodeWars, I mentioned to you, do not touch the sample test. Don't write anything in it. Don't alter it because it's gonna mess you up. Here's a perfect example. For some reason, I think I hit a key of some sort and it just inserted that character in there. So it wasn't reading it. And in the test right here, right there, it gave me this weird character. I'm like, what's this? Why is that there? So basically a weird bug that came out of nowhere. So let's just run the test. Okay, it's not passing. So let's see what's going on here. Let's make that a little smaller. Okay. There you go. Better visual of what's going on. So is even or odd? Expected even, instead got odd. So I'm passing nothing. I'm failing all. All right, it's all good. Is even or odd? True. Expected even, instead got odd. So did I get the logic backwards? Is that what I did? No. Oh, I'm comparing the wrong thing. Okay. Let me open this up a little bit. So here, I was comparing num instead of is even or odd. All right, so I meant to say if is even or is odd true or false, then no, return even or odd. So let's change this. So that's my bad. Or is odd. Pop myself back in the screen. So that looks much better. So let's run this. All right, let's run it, test it, and see what's okay. So now I'm getting the same result. Expected even. Oh, the spelling. Oh my god, really? Look at that. Make that bigger for you guys. See that? They wanted a capital E and I gave him a lowercase e. Okay, so let's change that. So even, odd. All right. Let's test it. Now I'm passing all 4. Yippee! I need like a bell. You know what? I'm gonna get like a soundboard or something, like a something. But I'm gonna clap right for myself right now. I'm not totally out the woods because like those edge cases, I'm expecting some weirdness to happen once I attempt this, but it's working. I'm passing all the tests. Everything is cool. I had a small error message on the spelling. The output wanted a capital E. And I was giving them a lowercase instead, but everything looks like it's passing. So we're gonna actually run this now and attempt it. So let's do that now, and let's get into the testing part, the full test week. So let's attempt the coding challenge. All right, guys. So we're gonna do that now. So let's attempt this coding challenge and let's see what happens here. Drum roll. Drum roll. Let's see. Everything passed. Yippee! All right, cool. I don't know what this is, but I made it up. I know what it is, but you know, I don't have those. I don't carry those things. Anyway, so everything passed. We have. Let me get myself out there. So we have everything passed. Awesome. Let me drop. Actually, I'm not gonna drop the screen. I need that for later. I wish I could make this bigger, and it's like this box I can make a lot bigger. But anyway, you can see everything's passed. So we did well there. The time, it has all of the cool, what is that, square? I have to get better at these. Right, boom, everything passed. Awesome. Pretty straightforward stuff, right? But you know, I wanted to make sure that I was logging, I was accounting for everything, like all of the edge cases and possible like information that's possible input that's being passed in. So that's why I went through this whole approach, right? So as far as the edge cases is concerned, reading it out, giving examples, approach. So we're done with the coding part. We've done the testing part is done. And what I'm gonna do is get right into the optimization piece and see if there's a way to identify whether this problem had like the time complexity of this problem. And it should be interesting because I've never done it where I never done this optimization part where I don't have any arrays or objects being passed in. So I don't know. We'll see how that works. But the testing part is done. We've passed. We've accounted for some edge cases that weren't necessary, but it was good to talk about to get some practice in. Never hurts. Okay, so let's get into the optimization piece. All right, so now we're at the optimization part of this coding challenge, and the solution did work. Right, so we used. Let me change my screens. So we used, I guess, again, confirm, please correct me if I'm wrong, but like a heuristic approach where we use some math or some logic to like help us for the most part. And I feel like I'm using that term wrong, but I just don't know. So this is why I'm doing these videos, so you guys can help me. Whoever's watching this, really appreciate you. Are we past everything? Let's see. So let's get it. Let's blow this solution up here. All right, I have enough time to do this in 15 minutes. So optimization. All right, cool. So from a time complexity analysis, complexity, I usually like, so far what I've been dealing with is like every time I see an example about like time complexity, there's like always some data structure involved. So here there isn't. So I don't know, like, what am I looking for? Like, how am I accounting for this if there is no like array or object or anything that I'm working with to apply some time complexity analysis to this? So I don't know. So let's see. Time and space. So I'm gonna look this up actually. Like, I don't want to just make guesses. Okay, let me actually put my video back up there. I don't want to make guesses for this part. Okay, and also I'm gonna add this solution to a gist, and I'm gonna put it in the description as well. You know, although you can just pause the video, but you know, I'm gonna add it in the description. You can reference it in one of my GitHub gist, however you guys pronounce it, tomato. So I'm gonna look this up. I have two variables, right? But I'm not running anything, so that's like more of I feel like a space complexity type of analysis, a question I need to ask. The only thing I'm doing really is a comparison, some logic that says if this thing is true or if it's false, return this. So I guess here's most of the challenge is trying to figure out the complexity of el tiempo, the time. All right, let's do this. So let's ask the question, how do I measure time complexity with no experience? That's, yeah, same. No data structure in my function. That's a long query. Let's make this bigger. Understanding time complexity with simple examples. A lot of students get confused while understanding the concept of time complexity, but in this article, we'll explain it with a very simple example. Imagine a classroom of 100 students in which you gave a pen to one person. Now you want that pen. Here are some ways to find the pen and what O order is. Big O. Awesome, this is cool. But I'm gonna save this for later. I'm gonna read that on the side actually. This is a nice, I just need something that gives me like something that says like I'm not working with any data structures. I'm just have two variables and a condition. Like, what is that in terms of like time complexity? I may have to go through my cheat sheet to be honest. Okay, here we go. In the above hello world, print once on the screen, so the time complexity is O of 1. Oh, look at that. Every time constant amount of time is required to execute code, no matter which operating system or which machine configuration you're using. So I'm not using a loop, so I'm gonna just not look at this. Where's the code example for here? So print. So the time complexity is constant time, big O of 1, because it's just printing that one thing. There's no iteration, nothing that we're looping through, nothing is growing as far as like exponential growth in the data that's being passed in, which is not, you know, it's just one thing that's being passed in. So that kind of makes sense now. Like, I didn't think about it that way. Let's dig a little deeper. This example here is showing a for loop that's iterating over 8 times roughly, and printing hello around 2, 4, 6, 8 times. So that is what is that? That's gonna be linear, right? The above hello world prints n times, so the time complexity of the code is linear. Yeah, O of n, meaning n is the size of the amount of times the print f is being, hello world is being printed, n being 8. So whatever 8 equals to, it'll grow to that amount. All right, I'm not using a loop, so I'm gonna just keep moving. This is giving me something to work with. So this is the first site I clicked on. I'm gonna click on one more site to see what else I can find to give me an idea of what the time complexity could be for our solution. And I'm gonna look at this and then the cheat sheet, and then I'm gonna call it there. How to analyze time complexity, count your steps. The iterative algorithm. What's the running time of the following algorithm? I don't like this one. I'm going to go, actually I lost the screen there, bummer. Let me open up that tab and let me go to how to analyze. Awesome. All right, so I'm gonna go, actually I didn't want that one. I wanted, okay. I'll just go to my cheat sheet. Let's see, where's my cheat sheet? Where is my cheat sheet? Computer science, algorithms. No, that's empty. Big old cheat sheet. There you go. These tabs I have been collected over the years, and a lot of this stuff is like outdated. The links don't work anymore, but they're very useful. I tag everything, keep track of everything. I'm always watching. Just kidding. There's nothing here as far as like, so these are data structures, right? I'm not working with any data structures. I'm not working with none of these, so I'm not sure if any of these make sense to me right now. I'm on a time crunch. I have to end this in 15 to 20 minutes, so array sorting algorithms, none. I'm not using any arrays. So in the event that I am not using any arrays, any Jada Pinkett Smith. Okay. Yeah, in the event that I'm not using any data structures, I believe that according to the other notes, the notes that I was there, that it's constant time, which I lost the page, but let's go back here. Right, so here I'm only printing one thing. I'm returning one thing, and this number is one integer being passed in all the time. So I'm gonna just go with those the initial notes that I found on the other website, right? So actually I want to find that. Is there a way I can go back to my history here? Heuristic pro, how to determine, oh, here we go. No, that's not it. That's the modulus thing. I'll just type it again. How to determine the time complexity of an algorithm without data structures. Something like that. I said something like that, and there you go. Where's that example at again? Print hello. This is the one I wanted. The above hello world prints only once on the screen, so time complexity is constant. All right, that's the only piece of information I can go with. Honestly, I don't really know how else I can measure this without any data structure. So I'm gonna say the time complexity for this problem, because I'm printing out one number, is constant time. Which is big O of 1, because I'm only printing out one thing at a time. As far as, so moving on to the space complexity. The space complexity stuff excites me, because I'm actually learning, man. This is actually cool. As far as the space complexity, I'm not sure how to, I don't have any, I mean, so I need to understand, do I count variables as part of the equation for space complexity? I am not sure. I'm gonna look that one up. So, and I have 4 minutes to do this. How to, and then we're gonna wrap this up. How to measure space complexity. There we go. Quora. Where can I buy it? No, I don't care about that. Go to Fiverr, man. Space complexity refers to the magnitude of auxiliary space your program takes to process the input. Iterative algorithms, I don't have that. For iterative algorithms, we have to consider the variables and data structures we declare in our program. To be more general, if we reverse any memory apart from the input, counts towards the space complexity. Is there a space complexity cheat sheet? Well, that's part of the other cheat sheet, but I'm not using any of these. And the data structure of just a simple variable is not accounted. I don't think it holds that much weight as far as memory is concerned, because those variables get blown away after the function is done. So it's like you don't need it no more. You know what? I'm gonna query this a little better. So let's say, do I account variables as part of the space complexity analysis? Is probably space complexity of algorithm study tonight. I need like pictures, man. They got like images, pictures I can roll with. I like pictures. Space complexity variables. Whenever a solution to a problem is written, some memory is required. I'm here, guys. To complete for any algorithm, memory may be used in the following variables. This include the constant variables, temporary variable values. Space complexity is the amount of memory used by an algorithm, including the input values to the algorithm to execute, produce itself. Some auxiliary space is confused with space complexity, but auxiliary space is the extra space or the temporary space used by the algorithm during its execution. Can you give me an example? There you go. Now let's learn how to compute space complexity by taking a few examples. A variable that has some equation a plus b plus c returns z. In the above expression are all integer types. So I'm kind of dealing with that. 4 bytes, 20 bytes. Because the space requirement is fixed for the above example, hence it's called constant space complexity. Let's have constant space complexity. So is it O of 1 because I'm just using a set of like numbers. So this example runs through a for loop, holds one variable, some variables being held as parameters here. So here it's saying, hence the total memory requirement will be 4n plus 12, which increases linearly with the increase of the input value size of n. Hence it's called as linear space complexity. So if the variable grows, if I'm holding a variable that has an array, from a space-time complexity side of things, is it because that it's growing? Do I apply like that same mindset to those? But what if I have more than one variable that have a couple arrays? Like I don't know how to calculate that. So I have to get better at the space complexity. I'm gonna look at one more site. I know my time has run out. I'm gonna run a little over and then cut down the break and get into the recap and cut down the recap to about a couple minutes, and we'll end there. I have a hard stop at 12:45, and we have a couple minutes left to get this figured out. So can I go back? dev. Here we go. Space complexity. Let's try this one. Whenever we write an algorithm or we want to perform analysis of an algorithm, time. So this is the equation, and this is the second time I'm seeing this equation to find out the space complexity for this. I just got to get better. I have to understand how to like put those values in that equation and like, you know, determine the space complexity. Right, so I'm gonna just keep going through this and see if they provide me with some more information. Oh, this is the same example from the website. So this looks closely to what I'm doing. Like, I feel like I'm finding the modulus, I get true or false, and I get like that constant thing. It's just one thing I'm getting back. I'm not growing anything exponentially as far as like an array. I'm not using any like really big like data types or data structures that hold, you know, values and stuff, a collection of things. So I'm gonna go with a guesstimate here and actually ask you guys to help me out. I'm gonna leave this in the notes below. As far as like the timeline is concerned, I'm gonna label it as help. I need help with identifying the space complexity. So at this very point, I'm asking for help to identify the space complexity for this particular coding challenge. If you can find more information, link it to me, tweet it to me, hit up my Instagram to let me know what the actual space complexity is for this problem, and some like backup information to support that, so I can better like read up on it as well. And I do take your word for it, but I just want to like have some reference points for myself. So I'm gonna say, based off this one slither of information that I saw twice, my understanding is that, you know, since it's producing just one result constantly, it's just one thing. There's there's nothing happening as far as like exponential growth. It's just one result, that it's going to be a space complexity of constant time. Okay, so I'm gonna go with that. And again, please correct me if I'm wrong and steer me in the right direction. Right, so we're gonna say O of 1 for the space complexity. So there you go, guys. So there it is as far as the optimization piece. I don't have time to actually like redo the problem in a different way. There are many ways you can do it, and off the bat we can have a ternary operator condition thing where I can just do this in one line. But you know, I add those when I need to, but for, you know, if I have to, like, you know, for brevity purposes I have to do that, then I'll do it. But I'm gonna leave it at this. This is pretty descriptive as to the direction I want to go, as far as like, it's very descriptive is what I'm saying, right? So we are done with the optimization piece. Cool. I've come to the conclusion that the time complexity and space is constant time for both. Please correct me if I'm wrong. And let's go ahead and get into this break. We'll cut the break short, about 2 minutes, and then get into the recap for this coding challenge, and then we'll call it quits from there. Enjoy your break. All right, guys, we're back. I just realized I forgot to submit this thing, so let's do that before we get into the recap here. So I'm gonna hit attempt. My current points is 186. I'm looking to reach 500 in this particular filter set of AQ with the fundamental set. So I'm gonna submit this now. So let's see how many points we generate from this. Unless it already happened, well, we'll find out in a sec. So while this is happening, as far as the recap is concerned, we definitely, this is the first. Oh, it went through. Awesome. 186. I think that was it. I think I had 184 before. So it worked. Let's go to the home page here. And where am I in the leaderboard? So I feel like I had 184. I need to go back a few minutes in the video. But I'm at 186. I'm catching up to Brian. Brian, what's up? I'll tag you on this part, but Brian is in the 10th position, and I'm gonna creep up and try to get to the #1 position there. So every Friday I'll be doing this. So cool. That worked. That was awesome. With regards to the recap, yeah. So we spent a lot of time here trying to solve this coding challenge with the REACTO framework set. This camera's bugging out on me. With the REACTO framework set, the REACTO problem solving skill set in place as far as like trying to solve problems here. So we did that successfully. We went through the repeat phase, the example phase. We went through the approach phase, testing it out with the unit test that CodeWars provides for us. And then we went over some optimization as far as like the time and space complexities analysis for a simple problem like that, which threw me in the loop because I never actually, every problem that I've seen has always dealt with some sort of data structure, me trying to figure out exactly, you know, the time complexity and space with data structures in place. In this case, that's not the case. We have like a simple function with some logic and holding 1 or 2 variables. So correct me if I'm wrong. Please look at that part. I'll tag the optimization part of this video and ask for help. So what's next? Monday I will be going over another coding challenge, and I'll start that process. There may be a possibility where I may take the week off, but right now I have Monday scheduled for the next stream to go through Algo Experts next coding challenge, which would be a brand new coding challenge. So we'll take the same approach there. And yeah, so that's next. As far as what's next for next Friday, if I do not take the week off, I'm just going to continue this process and go after the next coding challenge with the same filter set in place. Okay, guys. What else? Follow my social media as always. I have some good content there. Stay motivated. Keep going. This is a great way to learn. I'm revisiting a lot of fundamentals, which I've never seen, but also have seen at the same time, or may have forgotten and need to brush up on some stuff. It's always good to like go back to the basics. So this is a lot of fun for me. Now I have a goal to reach as far as like reaching the top #1 spot, which Dan has right now, which is one of my former students. So look out, Dan. I'm coming after you and everyone else for that matter, as far as this is concerned. So that's my competitive side talking. So guys, thank you. I appreciate it. This is built by Getroman, live code with Getroman, and I'm a channel dedicated to guiding aspiring software engineers, code newbies, to become a software engineer through motivational coding and through the documentation of my own journey, just to show that you can do it and you can keep going. And this YouTube thing is possible. Just I would advise everyone to do this as a up-and-coming developer, to get more eyes on you, to practice technical communication, and to keep going and to get your confidence up. So thank you for watching. I appreciate your time, and I'll see you in the next one, guys. Peace.